Alright, so this day, this video live, okay, so our tutorial is about graphing rational functions, okay? So graphing rational functions. Okay, functions. Okay, yes. All right, so graphing rational functions. All right, so I am going to teach you to graph rational functions in 3 steps. Okay, so what are those? First is find and draw the asymptotes. Second is construct the table of values. And then next is sketch the graph and find the domain and range of the function. Okay, let's say that we can encounter this kind of function. F of x is equals to 2x plus 5 over x minus 1. As you can see that this is a rational function. Okay, so for getting or for finding and draw the asymptotes, you have to first get the vertical asymptote. Okay, so there are 2 asymptotes of graphing when you are graphing rational functions. Okay, so we have vertical asymptotes and horizontal asymptotes, and note that there are 2 ways, no? There are 2 different ways in getting our asymptotes, vertical and horizontal asymptote. Okay, so first, by getting the horizontal asymptote, vertical asymptote, sorry. Okay, hold on. So there is a chat. Okay, so for getting the vertical asymptote, okay, so it says here that for those simple rational, the vertical asymptote occurs where the denominator equals to 0. So the same x values that is not in the domain. Okay, so that is what it says here in our guide. Okay, so for this, as you can see that the denominator here is x minus 1. Okay, so for our vertical asymptotes or the VA, okay, let's say that we will write this, vertical. Okay, okay, yes, it's vertical asymptote that, yes, is x minus 1. Okay, so let's equate this into 0. So x is equals to positive 1. Alright, so we have already our vertical asymptote, but let's try to create a graph first before we plot this, okay, in our graph. Alright, so before we proceed to horizontal asymptote, much better that we have to prepare first our graph where we can plot our points later. Okay, okay, so it is very difficult to to make a perfect line, a straight line, of course. Okay, so we have here the vertical asymptote, which is x is equals to 1. Okay, x is equals to 1. So let's create a dashed line. Okay, so it must be here. Okay, alright, so it is very easy, no? Okay, yes, then going downward. So this is the dashed line. It means that it is not part of the solution. Okay, so we have already the vertical asymptote. Now we have to get the horizontal asymptote. Okay, okay, so horizontal asymptote. For getting the horizontal asymptote, we have to follow the rule. Okay, so what are the rules of getting the horizontal asymptote? Okay, so there is a rule that if if the degree of the numerator is less than, so the degree of the numerator is less than the degree of the numerator. No, the degree of numerator is less than the degree of denominator. So our y is equals to 0. It means that if our y is equals to 0, our horizontal asymptote is along the x-axis. Okay? So for if ever the degree of our numerator is greater than, alright, so the degree of our numerator is greater than the degree of our denominator. So meaning to say there is no asymptote. Okay, no horizontal asymptote. Okay, no horizontal asymptote. Okay, so if there is no if the degree of numerator is greater than the degree of the denominator, it means that no horizontal asymptote. First thing we have to know is when we are getting the degree of the numerator and denominator, let's focus on the first term or the leading term of the given function. Okay, so the last rule, if the degree of numerator is equal the degree of the denominator, it means that our y is equals to a sub n over b sub d, where a and b are real numbers. So meaning to say, the value of our leading term in numerator is divided by the degree of the value of our denominator, in the given function. Okay, so let's make this clear. Alright. Okay, so say for example, the degree of our numerator is equal to the degree of denominator. So what you're going to do is to divide the value of the leading term of the numerator to the value of the leading term of the denominator. So that is why y is equals to a sub n over b sub d. Okay, so as you can see in our given here that 2x plus 5 over x minus 1, it means that their degree are equal. So as you can see that our leading term in our numerator, the degree is 1, and also for our denominator, the degree is 1 as well. Okay, so you have to just divide 2 over 1, which is the value of our numerator is 2, and also for our denominator, the leading term, the value is 1. Okay, so let's divide y is equals to 2 over 1. Okay, so y is equals to 1, and this is our horizontal asymptote. Okay, alright, so our horizontal asymptote is, okay, sorry, this is not 1. Okay, this should not be 1. This is 2 divided by 1, that is 2, of course. Okay. All right. Okay, so let's plot the horizontal asymptote in our graph. Okay, so starting from the 0, 0 coordinate points, let's have to count 1, 2. Okay, then 1, then going to this way, where our y is equals to 2. Okay, yan. All right. So now, next thing we have to do is to get okay, next thing we have to do is to construct a table of values. Okay, so the purpose of our table of values is to determine the direction of our line, of course, no, where the line will create a curve. Okay, so let's say, okay, let's create a table of values, x, and then, okay, so y. Okay, so for our guide for creating a table of values, let's focus on our vertical asymptote. Okay, where is it, or where it is located? Okay, so it means that, okay, this is our vertical asymptote started. So meaning to say, you have to take 3 numbers going to the left and 3 numbers going to the right, starting from this one, okay, and starting from this one, 3 numbers, at least 3 numbers. Okay, so except 1, okay, because 1 is the corresponding value of 1 is still undefined. Okay, so let's create, that is 1, so meaning to say that we have, okay, 0. Okay, hold on, so this is not, okay, this is negative 2, negative 1, 0, and then 2. Okay, we have to skip 1 because that is not part of the solution, as we all know. Okay, so this is our x and our coordinate points. Okay, so for getting the value of y, we have to substitute, okay, the x value to our given function, which is 2x plus 5 is equals 2x plus 5 over x minus 1. Okay, let's try a simple sample. F of x is equals to 2x plus 5 and then x minus 1. Okay, so we have here a negative 2, so f of negative 2 is equals to 2 times negative 2 plus 5 over negative 2 minus 1. Okay, so this will become negative 4 plus 5 over negative 3. Okay, so negative 4, so that will become 1 over negative 3. So 1 divided by negative 3, that is negative 0.33, and so on. Okay, so our coordinate points here is negative, okay, so negative 0.33. Okay, so and so on. Okay, so the process is continued, the same thing. So I will put the value, the corresponding coordinate points of negative 1, because I have here already the formula or the result. I solved this already. Okay, hold on. Okay, so I'll make this clear first because, you know, okay, this one. All right. Okay, so this is negative 0.33. Okay, so for negative 1, that is, okay, negative 1.5. And then next is, okay, for 0, that's negative 5. And then for 2, that is 9 positive. And then for 3, that is 5.5. Then for 4, that is 4.33. Okay, so next step is you have to plot this in our coordinate points, okay, or coordinate plane. Okay, so we have negative 2 and then 0.33. So let's try to use another color. Okay, so that is negative 2 point, and also 0.33, negative 0.33. It means that it must be here, 1, 2, and then 0.33. Okay, so it must be here. Okay, so our point must be here. Okay, next is negative 1 and then 1.5. Okay, this is 1, the 1.5 here, it must be here. Okay, the next is 0 and then negative 5. So this is 0, then you have to count 5 times, 1, 2, 3, 4, and 5. So our point must be here. Okay, then next is 2 and 9. Okay, so 2 and 9. Alright, so 2 and 9, 2 and positive 9. So they're both positive. So 1, 2, okay, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the point is here. Okay, next is 3 and then 5.5. Okay, so 1, 2, 3, 1, 2, 3, 4, 5, and then 0.5. So it must be here. Okay, next is 4 and then 4.33. Okay, so 1, 2, 3, 4, and then count 4.33 going up. So it must be 1, 2, 3, 4, and 0.33 here. Okay, so if we connect our lines, okay, let's use another color na naman. Okay, so if we connect the lines, so it must be like this. Okay, going up. Okay, yes. And then for here in this way, so it must be like this. 1, okay, so it must be like that. Okay, so this is our graph for this rational function, 2x plus 5 over x minus 1. Okay, so now let's write, okay, how to get the domain and range. Okay, so for our domain here, okay, as you can see the graph that domain, okay, for our domain, okay, so x over x is n equal to 1. That means the set of all x except 1. Okay, as you can see, okay, the set of all x except 1. Okay, as you can see that the one our vertical asymptote is located. So what about for range? Okay, okay, for our range, let's have y over, or y slash y is n equal to 2. Okay, so meaning to say that the set of all y except 2. Okay, so this is how we can sketch the graph using the given function f of x is equal to 2x plus 5 over x minus 1. Okay, so if you enjoy and learn this video, Okay, you can please subscribe and then hit the notification bell for you to be updated for my next video. Okay, I'll be making another video that is about rational functions and also logarithmic functions. Okay, so how to graph it, same thing. Okay, so that's all for now, and then thank you for watching. Goodbye and mabuhay.